Welcome ESP8266 and Sming fans. Today I'll demonstrate to you how to debug live on the device. I have the device here, you'll see it shortly, and on it we'll be demonstrating one of the sample applications which is coming directly with Sming, and we'll try also to change another application in order to be able to debug there. What you can see here on the right side is the ESP device that I'm having with a blinking application. So now let's start with our live debug example. First, you need to be sure that you have compiled it with enable gdb equals, if I can type it correctly, gdb equals 1. And then once you have this compiled, you have to flash it on the device. To flash it on the device, you don't need to flash the complete application, you just need to do something like this, flash app. This will start communicating with the device and it will start putting the information there. So soon we'll be able to start looking at our new application and to debug it actually. What I'll show you in the beginning is the text debugger, and then we'll go with the visual debugger. So make gdb is allowing me to create a new debugging session. Yes, I'd like to have a new debugging session. Now my computer communicated to the device. You can see that the blinking has stopped, and I can see where did I stop. So if I type list or just L, this will show me the lines of code. And what I can do is I can see some of the variables that are here. I can check their state. I can change their state if I want. But what I'll do is I'll put a breakpoint, a software breakpoint. I know that the software has a function called blink, and I'll put a breakpoint there. Break blink is the way you set a breakpoint. You can just also type br blink, and then this will set the breakpoint. Now let's again show you the device. I have here 10 out of a minute, I think. So I'm setting the breakpoint now. The device is still not blinking. Now let's continue with the running of the application. You can type continue or just C, and this will start with blinking the application. We have also here a special console that allows us to communicate with the device and put additional information. For example, we can grab a huge file from our PC and we can send it to the device without actually keeping it on the device because we don't have the space, and be able to check our source code if it's working with big devices. So now we stopped at the blink function. I can see again the listing of the function. This is how it looks like. I can go on the next line. I can type next or just N, and this will bring me here. If I press enter, the last entered command will be executed. So next again, this will cause the blinking to stop. So my LED will stop, and I can check, as I said here, the LED state. Here we go, and then I can continue. So if I type just C, it makes a continuation. I'm stopping again the same space. Let's go to the next line and let's continue. So now my LED will start shining. Wonderful. And so I can really debug my application. If you know all the commands, gdb, the console line is really useful thing, but not all the people know. Okay, so what we'll do is we'll go to another application that we're having and we'll try to debug this one directly Eclipse. It's called Basic Serial, and it allows us to see some more information about communicating with the device over the serial port. Now this application by default will not be able to debug, so we need to debug it to do some small changes. I already did them for you. I'll show you what was changed. So the first thing is, for those functions where you want to put breakpoints and where you want to enter, you need to put this attribute GDB IRM attribute. This takes care to put the function that will be debugging in IRM. Otherwise, you will not be able really to put a breakpoint here. This is limitation for device, and we cannot do anything more. And I have also breakpoints here and breakpoints here. Okay, so once I do this change, and these are the only changes that I'm having here, I need to recompile my application with, as you remember, enable GDB equals 1, and when that finishes, I need to again flash the new application, flash app. So this will send it to the device, and I'll be able to debug the application directly there. So as we said, this is a new while we're waiting for this to compile, what I'll do now is I'll go to my Eclipse. I already have started Eclipse. In here I created a new Eclipse debugging configuration, and what I did is, let me take a look here, debug configurations, and show you a bit. So I have basic serial that requires me to specify where is the out file. Then I need to specify that I'm using manual remote debugging launcher. That's a must, otherwise you'll not be able to set up the next things, which are, you need to specify in the debugger, first where is your debugger, I have it here. Then you need to specify the GDB commands that will be executed initially to prepare your debugger for the actual debugging. You can stop on the first, on some of the functions, as long as that function is in IRM, as we have done this for our application. Now, what else needs to be done is you need to specify a couple of things. So you need to specify, for example, here for the debugger, how to communicate with that debugger. I have specified here that I'm using serial, and this is my device, and this is the speed with which I'm talking with this device. Okay, now let's try and debug our application. Hopefully it will start a new debugging session, as you can see, and now I can go line by line, similar to what I was doing with the command line GDB, but this time I have a better visibility. So I can see what's happening, which command is executed. I can go, if I want, inside of the command. For example, here I'm able to see the variables that are visible for this scope. I can even modify some of them if I want, but I don't want at that very moment. I can go out, I can continue. What I'm really interested is something which we did recently. So this is the spiff mounting command, and I'm interested if it's working correctly. So I can go inside of this one. I can check if the storage was correct. Notice these functions are not really inside of the IRAM, but still you're able to go and to debug them. You will not be able to put a breakpoint. So if you put a breakpoint and you expect to come here again, this will not work. But if during your live debug you enter them, that's fine. And here I can see, for example, what's the configuration that I'm having, what are the lines that are executed. I can see what is the maximum allowed sector. I can check with the calculations that I have done if this is matching the correct stuff. Then I can check some things. I can even evaluate expressions before they are evaluated. So I can put something like this, and the result will be probably integer 0. So I'll not go in here, and so on it goes. I can really debug in here and use all the advantages of live debugging on the device. Any specific thing based on the device will be shown during that debug. Okay, that's for now. I hope you enjoyed it and you're ready to start debugging your own applications. Good luck!